Here's your solution to free response question number 3. First part A, says that they given us that the integral from -6 to 5 of f of x dx equals 7. Now the problem you see in looking at that is, well, it starts here at -2. So there's nothing to account for except that they do ask us in the end, all they want to know is what would be the integral from -6 to -2. Well, we can account for -2 to 5, and we can get that area. So -6 to -2 plus, or -6 -2 equals, that's going to be -6 to 5 minus -2 to 5. All right, well, they tell us that -6 to 5 is 7, so it's going to be 7 minus. Now, all we have to do is figure out what this integral from -2 to 5 is. Well, from -2 to 0, -2 to 0, your triangle above has the same area as your triangle below, so that's going to be 0. In this little area from 0 to 1, well, that's going to be -1/4, and then that's +1/4, so those become 0. Plus, all right, now, you've got a trapezoid here, or you have a square, which has an area of 1, and then a triangle with a height of 2 and a base of 1, so that's got an area of 1, so it's 1 plus 1, so it's 2 right there. Now, the trick is getting this region right here. And I did some shading off here. So you think about this as being a square minus the quarter of a circle. So it's going to be the area of this square, which is 3 by 3. So that would be 9 minus, and a quarter circle is going to be 1/4 pi r squared. Well, r is 9, so it's going to be 9 minus 9 pi over 4. Or you could just say 7 minus 11 minus 9 pi over 4. You could have stopped there, but we'll stop right there. Again, don't want to make any mess ups distributing the negative or anything. Let's just leave it alone and press forward. Part B. Part B asks us to evaluate 3 to 5 of 2 times f prime of x plus 4. So we're going to break this up into 2 different integrals. So it's 3 to 5. I'm going to say 2 times, Okay, so from that, this would be just 2 times f of 5 minus f of 3 plus, and this would be 4x from 3 to 5. So we have 2 times, all right, f of 5 is 0. And f of 3 is, they just happen to give us that information in the problem. They told us that it is 3 minus the square root of 5. And then plus 4 times 5, which is 20, minus 12. Now again, let's just stop there. Don't worry about reducing any further down than that. Okay, part C here. Part C defines g of x as being the integral from negative 2 to x of f of x dx, which is good here because it starts at negative 2. Again, we don't really know what's happening from negative 6 to negative 2, except we did get a solution, but that wouldn't help us as far as this is concerned. We want to know about extreme values here. So the extreme values exist, again, where g prime of x is equal to 0, and that happens to be where f of x is equal to 0. So let's see what our potential values are. Well, we could have negative 1. We could have 1/2. And then we could have 5. And technically, we could have negative 2. All right, g of negative 2 is going to be 0 because negative 2 to 2 is negative 2 to negative 2. Again, your upper and lower limits of integration are the same, so that's always 0. All right, g of negative 1, that's going to be positive 1/2. All right, g of 1/2, you've got, okay, again, that's 0 to there. Now, this little portion right here is negative 1/4. And then g of 5, well, we figured out g of 5 when we did all of this arithmetic here. It was just this portion here that was 11 minus 9 pi over 4. And that happens to be the largest of the values there. All right, on to part D. Now, when I look at part D, I start thinking that you're going to be wanting L'Hopital's rule. It just looks like a L'Hopital's rule situation. So we want to determine what would be the indeterminate form for it. So we have the limit as x approaches 1 of, and it gives us 10 to the x minus 3 times f prime of x. And then that's going to all be over f of x times the tangent inverse, no, not times, minus the tangent inverse of x. Okay? So we get 10 to the first minus 3 times, all right, well, what's f prime of 1? Well, right in here, we're sitting where we have a slope of positive 2. So it's 3 times 2. Now, if you stop right here and look, you're going to see this is not going to be 0. So this is going to end up not being a L'Hopital's rule problem. So if you tried taking the derivative of this first, you would have been in trouble. And as I look at it more and more, I'm glad we don't have to, because this is an inverse trig function we would have to be taking the derivative of. All right, we want f of 1. Well, f of 1 is 1. And the tangent inverse of 1, pi over 4 has that tangent of that value. So again, we could stop here, but you could also say 10 minus 6 is 4, so 4 over 1 minus pi over 4 would work as well. So that would be the limit as x approaches 1 for this value. So that was question number 3, free response. Again, I probably went through it a little fast. You may want to go through it slower, but I got several of you to turn it in. It started coming in a little bit late, but as y'all started turning them in, I was getting several responses. So keep up the good work. I will be posting the next problem I want for you shortly. They said that there would not be any calculator problem, or you can use your calculator on the test, but it's not required on the test. So the problems I'm pretty much going to be picking from now on for you to practice are going to be the problems from the non-calculator section. So I will keep giving problems, and if you keep working them, The next problem I assign will be another problem that I'm going to need you to turn in. I'll be sending that to you probably tomorrow via an email.